Today, I think one of the most exciting labs during the semester. Okay, we're gonna make our own telescopes and microscopes. Okay, so that's pretty neat. So before we start, how many of you had a telescope when you were like a kid or not a kid? Did you learn? Like, fairly a few of us. How was it? Was it cool to look at the stars and everything? Okay, nice. So if I ask you who invented the telescope, who do you think did it? Galileo, right? That's what people think. Is it true? No. Okay, that's the whole point. So the telescope was invented by Lippershey. He was a Dutch scientist in the 1600s. But what happened? He only used it for regular things on Earth. What Galileo did, he took that telescope and did something greater. He started, instead of looking down, he started looking up to the sky. So that allowed him to confirm, the theory of that the Earth was not the center of the solar system. Okay, then he got in trouble for that, but he did. Okay, so everybody thinks that he invented the telescope because he did something special. Instead of doing what everybody was doing, looking down on Earth and see things far come close, he started looking up to the sky, and he saw all the craters in the moon. He saw the moons in Jupiter and so many things. Okay. So before even we start with physics, we have our first lesson. We gotta try to be different, okay? Like think outside the box. And you don't need to create or invent anything, but if you, with things that we have now, you think different, you can do something great, okay? So now, wanna have these two lenses, okay? Like this. So now, for example, the whole point of the telescopes is that if this have a f2, okay, whatever this, let's call it f1 prime, okay? We have f1 here, and then the point like this focal point over here and this focal point here have to be at the same point, okay? So this is gonna be f2 and f1 prime, okay, and this is our f2 prime. Okay, this is our first lens, second lens. Okay, so we have to play with these two until we find that both focal points are at the same point. Okay, same distance, right? So how's gonna be the race? Since our objects are really far away, okay, let's say galaxies or even like outside in the tree, the distance between your telescope and the tree is way higher than whatever distance you have inside the lenses. Okay. So we want to consider them that they are in infinity. And when something is infinity, the rays are going to be fairly parallel, okay? Almost same, parallel to each other, okay? So let's do like this. I'll come like this. And the other one is going to be almost the same, okay? And then both are going to get reflected. But one is going to get a little more than the other one, okay? Something like this. So our first image is going to be at that point, okay? Good? Then we're gonna come here. This ray is coming here, this ray is coming like this, okay? And then they're gonna reflect like this. But what happened? These are gonna be diverging, okay? A little. And exaggerating here so you can see the difference. So they're not gonna touch at any point here. Therefore, it's not gonna be a real image. The image is going to be formed far away, okay? And you see magnification? Okay? So you don't have a virtual image, but you guys are able to see virtual images, okay? It's going to be inverted or not? Yes, okay? Magnify or diminish? Or it's going to be magnified? Magnify, okay? But the whole point is to get at this point, okay? These two guys. Okay, so we can create the image almost close to this focal point of the second lens. Better? Any questions about this? Okay, I know you guys, it's the first time you're seeing this, okay, so don't worry, just ask me, as always, just ask me whatever you want, okay? Okay, now try to find that point between both lenses. What's that? But
so we don't go in parallel from an object and then just
well, when you have an object, yeah. But what happens when you're like that far away? Then your rays are going to be parallel.
Okay. So there's no.
Yes, but really, really far away. Okay. It's still an object, right? Like a moon or the moon or Venus or whatever planet. Okay. So whenever you have an object that far away from your system, you consider like from infinity, right? So those parallels are going to be almost the same, almost parallel, but it's going to be a slight different. So, and that different, when it hits the first lane, they're going to diverge, like converge a bit differently. They're going to cross somewhere here, inverted image, okay? And then those rays are going to keep coming to the one by a slightly different difference, okay? It's going to hit here, but when it gets here, they're going to separate. They're not going to come together. So the only the image is going to go trace back down there, and the magnification is going to be like a lot. Okay? Makes sense now? Better? Okay. You have to make sure that the distance between these two guys has to be the focal point of this one plus the focal point of this one.
How does these like line up? Because we have 4 that are here, but only 5. I think the 5th is missing.
Yeah, there's one more here. So this one's yeah. Yeah.
Is it better to use 2
What,
big
or,
ones,
what,
or
what did you say to need the focal point of what? You need to add up.
So the point of the telescopes, okay, is like the focal point. I have to explain in the class because you haven't studied this in class, right? You haven't done this in class yet.
What?
The whole point, okay? So the focal point is this, imagine that is 20 centimeters, okay? So it should be somewhere here, okay? Like here and here, okay? The two focal points of the lens. Then the point is like this focal point, let's say is 10, okay? Have to be at that distance from the focal point of this one, okay? Okay. Well, this is the microscope. We're doing a telescope. Okay. So that's the main difference. Okay. So now for the telescope, it's important that both focal points are at the same point.
Okay. Oh, so we would have to move one there.
Okay.
One up. Yeah.
Does it make sense?
Has a shorter focal point.
This one. Okay, see that.
Okay. So just make sure that point is the same for both.
Okay.
So
Whatever lenses you are using.
on here, does this correspond with this one? Closer.
Yeah.
So like this one is this one.
Yeah, that one. Yeah, it should be that one.
so we have 300.
Okay.
This one's 300 millimeters, so 30 centimeters.
What happens to our other one?
Get closer to the lens and see what happens. Okay.
Yeah.
Can you see any magnification? So can you see something like really far? Kind of closer to you? The trees, yes, on the trees or the buildings down there. It's bigger. Okay. Now, if you want to just try to move one of the lenses around and see if you can find like more focused image and like or more magnified. Okay. That's the whole point today. We have to learn how to like mess around with it so we can find the best position. Okay.
Your eyes.
So what happened now?
It's better if your eyes closer to the lens. If you're looking far away, then it doesn't help.
So, do we see it's inverted or still?
It's inverted.
It's inverted. Okay. You see Tanner? How many? Let's see. How we see there?
guide it since it's inverted.
But do we really care when a star is inverted or not?
No.
Not really, right? Okay.
How do they fix that?
This is a whole because the problem with the telescopes is not just to magnify things. Then you have something that's called aberrations. Aberration because the lenses are not perfect. You want to have some defects in your image. So that's why they have like whole setup different to remove those little like defects.
They have multiple lenses, not just 2.
Yeah. It's to like try to correct those little aberrations. Good?